This question is about ethane dioic acid, COOH brackets 2, and ethane dioate ions, COO minus brackets 2. Part A. The ethane dioate ion shown below can act as a bidentate ligand. Fe3+ forms a complex ion with 3 ethane dioate ions. The complex ion has 2 optical isomers. Draw the 3D shapes of the optical isomers. In your diagrams, show the structure of the ethane dioate ligands and the overall charge. The key parts of this question is that we're using Fe3+, and that will help when working out our overall charge. Then we need to also factor in the charge of the bidentate ligand, which is minus times 2, so it's 2 minus. And we are forming 2 optical isomers. So optical isomers, when we draw them 3D, they will be mirror images of each other. So next we need to draw the 3D shapes, so that means using wedges. We will have Fe in the centre, and it will be an octahedral layout of wedges, which is something that you need to know because it comes up quite a lot when talking about transition metals, and so it's really useful to make a revision resource of. Next we need to bond our ligands to our central metal ion, and it will bond with the negative oxygens. So all around our 3D structure or shape, we will bond with oxygen. And then we need to draw the rest of the ligand. So to start, we could have the ligand on the left and then going around the shape to complete it, making sure that when we draw our optical isomer, we have the mirror image. Next, we need to work out the overall charge, so square brackets, and we have Fe3+, and then 3 ligands with a 2 minus charge. Therefore, the overall charge would be 3 minus. Next, drawing our second 3D shape, or our optical isomer. Again, we have the same layout, so Fe in the middle, with our octahedral layout of wedges, with 2 dashed at the top and 2 solid wedges at the bottom. Again, it's bonding to the negative oxygens in the bidentate ligand, or the ethane dioate ion. But this time we're going to have the rest of the ligand being the mirror image of the structure we've already drawn. So, as you can see, we can imagine a mirror line, and that is what we're using as our guide to complete the shape of this optical isomer. And then once we've completed the shape, we need to add its overall charge, which would be the same. It would be 3 minus. To get the 3 marks for this question, you get a mark for each correct optical isomer and their 3D shape, and then you get a mark for the correct overall charge, so 3 minus. Part B. Ethane dioic acid COOH brackets 2 is present in rhubarb leaves. A student carries out a redox titration using aqueous cerium 4 sulfate, Ce brackets SO4 brackets 2 aqueous, to determine the percentage by mass of ethane dioic acid in rhubarb leaves. In the titration, Ce4+ aqueous ions oxidize ethane dioic acid in hot acid conditions. Ce4+ aqueous ions have a yellow color. Ce3+ aqueous ions are colorless. The student weighs 82.68 grams of rhubarb leaves and extracts ethane dioic acid from the leaves. The ethane dioic acid is added to dilute sulfuric acid to form a colorless solution, which is made up to 250 centimeters cubed with distilled water. The student heats 25 centimeters cubed of this solution to 70 degrees Celsius and titrates this volume with 0.05 moles per decimeter cubed CeSO4 from the burette. The student repeats the titration to obtain concordant (consistent) titers. Part 1. This titration is self-indicating and the student does not need to add an indicator. What colour change should the student observe at the end point? Firstly, for this question, we need to look at where we're told a colour. So we're told that Ce4+ ions are yellow in colour and that Ce3+ ions are colourless. We're also told that ethane acid is added to dilute sulfuric acid and forms a colourless solution, and that this colourless solution is titrated with CeSO4. So that would be Ce4+, because sulfuric acid, or the ion in sulfuric acid, SO4, has a 2- charge, and there are 2 ions, so therefore it must be Ce4+ to have an overall charge of 0. So that would mean that our colour change for this titration is from colourless to yellow. Now, where a lot of people fell short on this question is they looked at the ions and the Ce4+ ion going to the Ce3+ ion, so yellow to colourless, but that's not what we're looking at. We're looking at the titration itself, and what we're doing is we're titrating a colourless solution with a yellow coloured ion. So colourless to yellow. To get the mark for part 1, you need to say colourless to yellow. Part 2, calculate the percentage by mass of ethane acid in the rhubarb leaves. Give your answer to an appropriate number of significant figures. Firstly, with this question, we need to work out the titers of the titration results. So that would be taking the final reading and subtracting the initial reading. So for titration 1, that would give us 23.25. For titration 2, that would give us 23.50. Notice I'm giving all of my answers to 2 decimal places because that is what you would do when recording volume in a burette. And then for titration 3, we're left with 23.15. So next we need to work out the mean titer. So the mean titer would be using the concordant results. The concordant results are within plus minus 0.10 centimeters cubed of each other. So that would be titration 1 and titration 3. That would give us a mean titer of 23.25 plus 23.15 divided by 2, which equals 23.20 centimeters cubed. Using the mean titer, or the volume, and the concentration of CeSO4 or Ce4+, we can then use the equation triangle of NV times C to work out the number of moles of Ce4+. So that would be 23.20 times 10 to the negative 3, because we're converting centimeters cubed into decimeters cubed, and then multiplied by concentration, which is 0.05, and that would give us a number of moles of 1.16 times 10 to the negative 3 moles. These are the moles of Ce4+, and we're trying to work out the moles of ethane acid, so we need to look at the equation. Of Ce4+ to ethane acid, that's a 2:1 molar ratio. So to work out the moles of ethane acid, we take 1.16 times 10 to the negative 3 and divide by 2, which gives us 5.80 times 10 to the negative 4 moles of ethane acid in 25 centimeters cubed. But we want the number of moles in 250 centimeters cubed. And it's because we're taking a 25 centimeter cubed sample, but overall we have 250 centimeters cubed. So we have a factor of 10 we need to account for. So that means we need to do 5.80 times 10 to the negative 4 multiplied by 10, which gives us 5.80 times 10 to the negative 3 moles of ethane acid, COOH, brackets 2, in 250 centimeters cubed. We're asked to work out the percentage by mass, and we're going to do this using an equation triangle of mass over moles times relative formula mass. So we have moles and we want to work out mass. So we need the relative formula mass of ethane acid, and we're going to multiply our number of moles by this number. So that would be 5.80 times 10 to the negative 3 multiplied by 12 plus 16 times 2 plus 1 times 2, all in brackets. So 12 comes from carbon, 16 times 2 is the 2 oxygens, and plus 1 is a hydrogen, all multiplied by 2 is the relative formula mass of ethane acid. And that would give us 0.522 grams. Finally, working out the percentage by mass, we need to do 0.522 divided by the mass we're told in the question, 82.68 grams. So that's what we're going to divide by, 82.68, and then we're asked for a percentage, so multiply by 100. That gives us 0.631% to 3 significant figures, because we're told in the question to give our answer to an appropriate number of significant figures, in this case 3, making our answer on the answer line 0.631. To get the 6 marks for this question, you get a mark for correctly working out the mean titer, or 23.20 centimeters cubed, a mark for working out the moles of Ce4 plus correctly, 1.16 times 10 to the negative 3. You get a mark for working out the number of moles of ethane acid in 25 centimeters cubed, which is 5.8 times 10 to the negative 4 moles. And then you get a mark for working out the moles in 250 centimeters cubed, or 5.80 times 10 to the negative 3 moles. You then get a mark for working out the mass of ethane acid and the percentage by mass of ethane acid, so 0.631, and giving your answer to 3 significant figures. That gets you your final 6th mark.